The sky was supposed to be empty that night, yet, as the last instruments on the La Palma Observatory scanned the outbound trajectory of 3I, Atlas, the darkness flared with a thin, filamentary light. It wasn't sunlight reflected off dust or gas. It was colder, steadier, and seemed to pulse in exact rhythm with the observatory's own signal relay. For 3 minutes, the comet glowed in a way that broke every thermal model in the catalogue. When the pulse stopped, so did the data stream. It was as if the cosmos had blinked back. No one announced the finding right away. The first reports came buried in nightly logs from amateur astronomers in Chile and South Africa, who compared their data and found identical patterns. Their images showed a tail brightening at a rate 5 times faster than predicted, despite the comet's distance from the Sun increasing. To the naked eye, Atlas was shrinking to invisibility. But spectroscopically, it was roaring to life. That inversion light without heat, motion without cause, became the first sign that something fundamental was missing in our understanding. By dawn, NASA's Deep Space Network had recorded residual emissions from the same region of space. They were subtle, wideband, and asymmetric, an electromagnetic whisper stretching across multiple frequencies but never repeating. Analysts flagged the anomaly as non-thermal coherent emission, a phrase that hinted at structure but offered no comfort. Within 24 hours, similar detections were reported from Japan's Yasuda Station and the European Deep Space Tracking Array near Cebreros. The comet had become a point of global attention again, not for its beauty, but for the quiet defiance it showed toward physics itself. Publicly, the agencies described the signal as statistical noise, but internally, leaked memos revealed a scramble to recalibrate instruments. The data didn't fit with any known interference source, and attempts to simulate it yielded unstable patterns. The fact that every observatory's equipment behaved differently made things worse. It suggested the phenomenon wasn't instrument error, it was environmental. Something in deep space was reacting differently to each observation. Astronomers began to argue in code review forums. Some said the emission was due to outgassing from volatile ices, complex hydrocarbons sublimating in vacuum, creating temporary plasma jets. Others pointed out that the gas jets appeared synchronized, timed as though responding to tidal shifts in the solar wind. Coincidence, perhaps, but the alignment held for 5 consecutive nights. Every flare, every brightening matched a predictable interval, as though governed by a rhythm deeper than chance. When ESA released their mid-year bulletin, the section on 3I, Atlas, contained a new term, self-consistent luminal variation. No one explained what it meant. The phrase vanished from later versions of the report, replaced by generic language about photometric variability, but archived versions survived online for a few hours, long enough for researchers and citizen scientists to copy them, compare notes, and notice another detail. The coordinates listed for Atlas's core brightness didn't align with its visible nucleus. It was offset, slightly by about 3 kilometers, implying the brightest emissions were not coming from the core at all, but from an invisible locus nearby. That offset set off a chain of sleepless nights across observatories worldwide. If the light wasn't coming from the nucleus, what was generating it? Some suggested it was a fragment, a secondary body breaking away and igniting through internal chemistry. Others proposed a dust shell behaving like a photonic mirror, reflecting sunlight through aligned ice crystals. But neither model accounted for the stability of the pulse. The pattern persisted far longer than volatile outgassing should allow. Something was sustaining it. In the corridors of the Jet Propulsion Laboratory, quiet meetings began to form. One internal report, later leaked to a science journalist, compared Atlas's spectral energy distribution to that of a low-temperature maser, a phenomenon normally found in molecular clouds near dying stars. Masers amplify microwave radiation coherently, like natural lasers operating in space. But comets don't do that. They scatter, they emit, they dissipate, they do not amplify. And yet, the data said otherwise. A strange duality emerged. The comet appeared to lose mass while its energy emissions increased. According to thermodynamics, this was backward. To radiate more, a body should expend more, yet Atlas seemed to feed on its own decay, converting disintegration into luminescence. Some theorized that trapped volatiles could create feedback between sublimation layers, an internal echo of heat bouncing between thin crusts of refractive ice. It was possible, but barely. The energy conversion efficiency needed to make it visible was beyond any measured cometary process. The story reached the public sphere in fragments. science communicators tried to explain the anomaly in calm tones, stressing the limits of observation. "We're seeing the universe surprise us," one astrophysicist said in a televised segment, but her face betrayed unease. Behind the neutral phrasing was the fear that maybe, just maybe, the comet wasn't following the script of known chemistry at all. Online forums filled with speculation. Some amateurs overlaid the timing of the brightness pulses with Earth's magnetospheric variations and found weak correlations. Others claimed that when the comet pulsed, minor radio interference appeared on the 812 MHz band globally. The connection was unproven, likely spurious, yet it added an air of coordination as though something distant was faintly aware of its observers. Scientists dismissed the idea, calling it pareidolia on a planetary scale. But privately, many began rechecking their calibrations, unwilling to ignore coincidences too neatly aligned. The most unnerving discovery came not from professional observatories but from a small Antarctic research station equipped with a neutrino detector. During one of Atlas's most intense brightness peaks, their sensors logged a cluster of low-energy neutrino. Its tiny, ghost-like particles rarely correlated with cometary activity. The signal lasted only minutes. Statistically insignificant, perhaps, yet when compared to the comet's photometric curve, the alignment was exact. The chance of coincidence was less than 1 in 10,000. Still, correlation isn't causation. The universe is vast, and coincidences happen. But when coincidences start to repeat, science begins to tremble between data and doubt. The agencies knew this. They issued no denial, no confirmation, only silence. And silence, as history shows, is its own kind of answer. Weeks later, when 3I, Atlas, crossed the heliopause and drifted toward interstellar dark, its final readings were relayed by one of NASA's long-range solar probes. The instruments recorded one last flare brighter, sharper, perfectly monochromatic. Then the signal flattened. The probe's orientation sensors momentarily lost lock, as if nudged by a passing wave. When telemetry returned, the comet's spectral trace was gone. Not dimmed gone. For 3 days afterward, radio telescopes around the world picked up a low, rolling resonance from the direction where Atlas had been. It wasn't structured enough to be a signal, not random enough to be noise. A resonance between matter and absence, a memory of light. Even now, no one agrees on what that final emission was. Some call it a plasma artifact, others a transient echo in the solar wind, but a few quietly, cautiously suggest it was something else. A release. As though the comet, having finished its crossing, left behind a whisper of the rules it refused to obey. And in that whisper, the universe reminded us that every time we believe we've measured its boundaries, it moves them. That knowledge itself is a moving target, flickering like the tail of a comet vanishing into the dark. If 3I, Atlas, can brighten as it leaves the sun, what else might glow when the universe turns its back? The data arrived in pieces, small, cryptic fragments trickling through official channels like dust through fractured glass. NASA's release schedule for 3I, Atlas, had been set months in advance, yet suddenly, every dataset came staggered, incomplete, and inconsistently formatted. Some packets contained raw spectra without timestamps, others timestamps without spectra. The pattern was too chaotic to be accidental, too coordinated to be random. When the European Space Agency uploaded their observational summary, independent analysts immediately noticed that several spectral bands were missing precisely the ones overlapping with the anomalous emissions seen weeks earlier. The redacted frequencies weren't empty. They were replaced with static placeholders, white blocks where information should have been. A few researchers tried to reverse engineer the deletions by comparing file sizes, discovering subtle compression signatures that implied more data once existed but had been manually stripped. At the Harvard-Smithsonian Center for Astrophysics, a team attempted to reconstruct the missing data using interpolation models. The results were unsettling. The reconstructed emission curves didn't behave like gas or dust. They behaved like modulated carriers, frequencies rising and falling in harmonic progression. It wasn't music, but it wasn't chaos either. It was ordered fluctuation, structure hidden beneath static. Within days, message boards and encrypted science forums lit up with arguments. Some accused the agencies of intentional obfuscation, others defended them, claiming that data redaction was routine to avoid misinterpretation. But as more partial datasets appeared from JAXA, Roscosmos, and the South African Large Telescope, the same pattern repeated: missing bands, mismatched timing, and incongruent coordinate markers, as if each institution was looking at the same event through a slightly different universe. The public narrative stayed calm. Official statements framed the discrepancies as instrumental harmonization issues, but the independent research community didn't buy it. Too many anomalies, too much coordination in the errors. A growing faction began to suspect an underlying protocol, an agreement to withhold data until internal consensus formed. Yet no one could find evidence of such a pact, only silence, and the faint trace of an erased signature in the data logs. Among the leaked internal communications, one stood out. A brief message between two ESA analysts read simply, "We're seeing coherence above noise threshold, advise caution before public posting." That phrase, coherence above threshold, became a quiet rallying cry for those who believed something extraordinary was unfolding. Because coherence implies order, and in the language of physics, order means intention, whether natural or otherwise. Meanwhile, ground-based telescopes continued to observe Atlas's fading path, gathering what little light remained, but even the fading turned out to be misleading. The comet's optical output dimmed, yet its polarization signature intensified. Polarization, the orientation of light waves, usually random in cometary reflection, began to show repeating alignments. One polarization vector rotated cyclically, as though tracing a hidden geometry. The Cerro Paranal Observatory in Chile published a short technical note suggesting possible paramagnetic influence in cometary dust alignment. The idea was simple. If magnetic grains aligned with an external field, a light could appear polarized, but the strength of alignment implied a magnetic field orders of magnitude stronger than any measured in comet tails. To create that pattern, the comet would need either an internal magnetic generator or interaction with a field not originating from the sunday. Speculative models blossomed. Some proposed that 3I, Atlas, had captured a sheath of magnetized plasma from interstellar space, acting as a conduit for charge flow. Others pushed further, suggesting that the comet was not merely reflecting solar particles but reorganizing them, turning the solar wind into a structured medium. That hypothesis skirted dangerously close to science fiction, but in the absence of full data, imagination filled the void where evidence should have been. On the forums, one physicist wrote, "If this pattern persists, we may be looking at a system operating beyond equilibrium thermodynamics, a naturally emergent feedback between radiation and matter." Another replied bluntly, "Or someone edited the telemetry." Behind the scenes, NASA's data integrity team began cross-checking timestamps from multiple observatories. The findings deepened the mystery. Every dataset showed microsecond-level discrepancies too consistent to be random jitter, too small to indicate distance error. One theory emerged that the source itself was emitting in temporal phase shifts, meaning the signal didn't just vary in brightness or frequency, it drifted in time. If true, the comet was creating time-separated echoes, like a pulsar running on chemical instead of nuclear fuel. A meeting convened between NASA and ESA data leads produced a 22-page memo titled Temporal Phase Artifact Mitigation. The document, meant for internal circulation, leaked within hours. It concluded with one sentence that captured global attention. "At present, we cannot rule out the possibility that 3I, Atlas, is generating self-modulated emissions consistent with coherent resonance phenomena." The public read that as, "the comet might be talking." Astrophysicists scrambled to clarify. They explained that coherent resonance doesn't mean intelligence. It simply refers to self-sustaining physical systems like lasers, masers, or plasma oscillations. Yet that clarification did little to calm speculation. The word self-sustaining lit a fire under the imagination of millions. If the comet was self-sustaining, was it alive? Was it a machine? Or was it simply a cosmic accident mimicking intention? Meanwhile, a separate data leak from a private telescope array in Australia revealed another wrinkle. During one of Atlas's final recorded brightenings, the instruments detected a secondary emission trail, an elongated filament parallel to the comet's path but slightly offset. It was fainter, colder, and drifting behind as though tethered by invisible force. The team labelled it residual vector artifact, yet several independent analyses suggested it might not be an artifact at all, but the wake of something moving with the comet. The agencies ignored those claims publicly, but quietly ordered extended observation. When the secondary trail failed to reappear, official channels declared it a processing error. But archived frames told a different story. The faint thread had indeed been there. measurable, consistent across multiple cameras. If it wasn't an artifact, then the simplest explanation was interaction, the comet shedding a structured magnetic or plasma trace as it left the heliosphere. Such a trace could store information if one knew how to read it. Plasma retains memory through field topology. Its twists and knots can encode data much like magnetic tape. The idea was speculative, nearly heretical, yet some plasma physicists began to whisper about it at conferences. What if 3I, Atlas, was not just reflecting cosmic conditions but carrying them an interstellar recording medium, archiving environments from its journey between stars? That possibility, while purely theoretical, redefined the comet from object to messenger, and once an object becomes a messenger, every gap in its data starts to look intentional. Within weeks, the data chaos turned into geopolitical noise. Rival nations accused one another of withholding findings. The United Nations Outer Space Committee requested a joint audit of all shared telemetry. The motion was deferred, too sensitive, they said, too uncertain, and beneath the bureaucracy an unspoken tension grew. No one wanted to be the first to admit what they didn't understand. By the time a summary report was released, the comet was long beyond reach, its light reduced to background haze. But within that haze, high-resolution analysis found faint periodic modulations, consistent with rotational tumbling but offset by a fraction of a degree every cycle. It was as if the comet's spin was adjusting deliberately, correcting itself against invisible currents. The analysts wrote it off as coincidence, statistical noise from low signal to noise ratio. Yet, deep in the metadata, one researcher found something chilling. The phase corrections matched precisely the missing timestamps from earlier datasets. The comet's glitches were mirrored in human records. Our instruments failed when it shifted. The more we observed, the less we understood, and the less we understood, the quieter the agencies became. By mid-year, no new data releases came, only retractions, revisions, and the cold assurance that further analysis is ongoing. The public's interest waned, the forums quieted, but among the small circle of researchers still comparing fragments, a single haunting question emerged. If 3I, Atlas, was recording the universe, what exactly was it saving? It began as a rumour among radio astronomers, an unconfirmed whisper about a low, steady hum hidden beneath cosmic noise. The signal was too faint to appear on public sky maps, too persistent to dismiss. It surfaced first at the Parkes Observatory in Australia, then again in archive data from the Allen Telescope Array. Each detection shared the same anomaly, a low-frequency oscillation near 0.16 Hz, repeating with a near-perfect 21-minute cycle. It came from the region where 3I, Atlas, had last been seen before vanishing beyond solar reach. At first, the detections were brushed aside as interference, ground resonance, atmospheric echo, or digital harmonics from satellite traffic, but the pattern didn't fit any known source. It wasn't geostationary, it wasn't solar, and it didn't shift with ionospheric activity. Instead, it followed the comet's former trajectory with unnerving precision, as though something in interstellar space was still speaking softly into the electromagnetic dark. A handful of researchers began comparing notes privately, using encrypted emails and anonymous forums. Their findings hinted at something stranger. The oscillation wasn't just periodic, it carried sideband frequencies that drifted in harmonic relation to each other, forming intervals similar to those in acoustic resonance. That wasn't random, that was structure, yet no natural mechanism could explain coherent sidebands at such low energy. The first formal report came from a small team at the University of Toronto. They published a preprint suggesting persistent low-frequency coherent resonance correlated with the exit vector of 3I, Atlas. Within hours, the paper was withdrawn, no reason given. A day later, the author's institutional emails stopped responding. The event barely made headlines, but among those watching closely, it was a seismic moment. A signal existed, but no one was allowed to analyze it. When the National Radio Astronomy Observatory cross-checked its own archives, they found the same pattern embedded in background readings from months prior, far weaker, but undeniably there. The signal had been present even before Atlas reached the heliopause. The discovery raised an unsettling question. Had the comet been receiving the signal all along, rather than generating it? NASA's Jet Propulsion Laboratory quietly launched a data audit of the Deep Space Network. Within internal reports, analysts noted that several of their antennas had experienced phase drift synchronization anomalies, exactly matching the signal's periodicity. Yet when journalists requested comment, the official response was silence. No anomalous readings confirmed. But in science, silence can sound louder than any denial. As the weeks passed, amateur radio astronomers around the world began tuning into the frequency band, hunting for the elusive hum. A community formed a global vigil of sorts, scanning the sky night after night. What they found wasn't steady. The signal waxed and waned, fading for days before returning stronger, shifted slightly higher in pitch, as though adapting. At times, two parallel tones emerged, merging and splitting like interference between overlapping voices. Some called it a standing wave of the interstellar medium, a byproduct of charged particle flows left in the comet's wake. Others whispered of modulation, an intentional shaping of the wave by some yet unknown process. The debate polarized the community. Theories bloomed, from the plausible to the impossible. One physicist compared the oscillation to Schumann resonance's Earth's own natural electromagnetic heartbeat, but inverted, broadcasting outward instead of inward. In one leaked transcript from a European Space Agency meeting, a project director remarked that the frequency spacing shows coherent phase alignment exceeding statistical expectation by 3 orders of magnitude. That statement alone, once shared online, fueled a new wave of speculation. Was the signal carrying information? Cryptographers entered the conversation. Some attempted to decode the hum by treating its phase shifts as binary sequences. Others applied linguistic entropy analysis, searching for patterns akin to syntax. The results were inconclusive: too much noise, too little data, but one algorithm found recurring distributions of intervals consistent with base 3 encoding. It might have been coincidence. It might have been the first whisper of order from beyond the stars. Amid the growing frenzy, official institutions began retracting data access. Public radio archives closed, citing storage reorganization. The Canadian Hydrogen Intensity Mapping Experiment, CHIME, which had also picked up the low hum, suddenly restricted its raw logs. And when a graduate student in France uploaded a processed dataset to an open repository, it vanished within hours, replaced by a notice citing data ownership disputes. The silence deepened. Behind the scenes, independent researchers reconstructed fragments from cached data and found something even more haunting. Each time the hum intensified, the sun's solar wind density dropped slightly, as though the space between them was momentarily reordered. The correlation wasn't perfect, but strong enough to hint at coupling a delicate tug between interstellar and solar systems. It was impossible under known physics, yet there it was, in the numbers. One astrophysicist put it bluntly: we may be observing a communication between systems, one natural, one unknown. Still, correlation is not causation. Every attempt to replicate the finding under controlled models failed. The hum remained, but its source refused to localize. It moved when measured, as if aware of attention. The universe, it seemed, was hiding behind its own echoes. A radical hypothesis emerged from the Max Planck Institute. If the comet's plasma tail had been laced with superconducting filaments, frozen magnetic flux tubes, it could resonate under interstellar magnetic compression, producing coherent low-frequency emissions. That would mean 3I, Atlas wasn't emitting the signal, but left behind a kind of resonant cavity, a ringing wound in the interstellar medium. The team called it cosmic aftersound. The term caught on. But others weren't satisfied. They noted that the harmonics ratios were not random. They followed a precise 3-5-8 relationship, reminiscent of Fibonacci sequences found in organic growth patterns. That numerical coincidence, combined with temporal drift, gave rise to an unsettling metaphor. What if the comet's chemistry had encoded its environment into physical rhythm, translating cosmic data into pulse? A few dared to ask if the signal was trying to replicate something, perhaps the structural code of its origin system, replaying itself endlessly through resonance. It was speculation, yes, but one grounded in a troubling consistency. Every harmonic mapped to a distinct spectral band previously redacted from the official datasets. Meanwhile, observatories began reporting equipment failures. Receivers tuned to the hum's range overheated or lost calibration. Power surges appeared unrelated to atmospheric activity. Engineers blamed routine stress, yet the failures clustered around antennas pointing at the same coordinates. It wasn't proof of causation, but it fed a new superstition among technicians that the hum didn't like to be measured. By late 2026, public attention had dwindled. leaving only the fringe and the faithful listening to the void. But on December 3rd, a breakthrough changed everything. A retired engineer analysing archived chime data discovered that when the signal was sped up by a factor of 12, its amplitude envelope formed a repeating pattern identical to the intensity curve of the original comet's brightening months earlier. It was as if the hum was echoing Atlas's light signature, compressed into sound. For some, that was proof enough that the signal and the comet were inseparable, two halves of the same phenomenon, one optical, one acoustic. For others, it was merely coincidence, the universe's way of tricking pattern-seeking minds. But for those still watching the dark, it was an invitation. Across observatories, one phrase began appearing in logs and private chats: "The comet is still speaking." It was never spoken aloud in official meetings, yet everyone knew what it meant. The line between science and myth had thinned to transparency. And through the hum, subtle and steady, the universe seemed to breathe a heartbeat of silence wrapped in sound. If the echo of 3I, Atlas, can still shape the air between stars, then what exactly is transmitting, and what, if anything, is listening back? It began with dust microscopic, unremarkable, the kind that usually dissolves into anonymity among millions of cosmic grains. Yet, in the sterile rooms of NASA's Johnson Space Center, the samples collected from high-atmosphere collectors told a different story. They bore isotopic fingerprints matching those previously associated with 3I, Atlas, fragments of its passing that had drifted into Earth's upper atmosphere months after its departure. No one expected to find anything unusual. They were wrong. The dust was alive in a chemical sense, reactive far beyond equilibrium, refusing to settle into the inert stability characteristic of interstellar debris. Under controlled vacuum conditions, its molecular bonds shifted, breaking and reforming in sequences that shouldn't occur without an external energy source. The reactions produced neither heat nor visible emission, only subtle infrared flashes detectable with hyperspectral instruments. The flashes pulsed irregularly, as though tracing a rhythm buried in molecular vibration itself. At first, analysts dismissed it as contamination, but the isotopic ratios didn't match anything terrestrial. The carbon signature was skewed toward heavier isotopes, while oxygen bore an anomalously high O18 fraction characteristics found only in pre-solar grains from dying stars. Yet these grains were too organized, too uniform, almost engineered. Under an electron microscope, their structures revealed layered lattices of carbon and silicate, interwoven with voids in regular spacing, voids that repeated in ratios, mirroring those of the low-frequency hum detected months earlier. The realization hit slowly. These weren't random mineral matrices. They were patterned, ordered like a crystalline logic. Nature rarely builds in ratios that echo harmonics. And yet, here they were, molecular fossils that seemed to remember a song. NASA called an emergency review board. The initial report, later leaked, labeled the phenomenon metastable reactive lattice phase, a phrase meant to sound technical while hiding the unease behind it. The structure behaved as if it were self-healing. When damaged by microlasers, its bonds rearranged, restoring partial symmetry within hours. The mechanism was unknown. No external energy was added. It simply refused entropy. In physics, there are no miracles, only models not yet refined enough to explain what we see. But here, the models broke entirely. The dust violated fundamental thermodynamic expectations. It exhibited spontaneous bond migration chemical self-repair with no known driving force. Some theorized catalytic tunneling, others quantum coherence between lattice nodes. None could explain the macroscopic coherence over such scales. The European Space Agency's Materials Division ran parallel tests in isolation. Their results matched NASA's findings but added one more anomaly. The samples exhibited weak magnetic alignment when exposed to alternating fields, as though remembering previous stimuli. This memory magnetism hinted at spin order embedded within the structure itself, a feature of certain quantum materials but unheard of in cosmic dust. When the findings were quietly shared with CERN's condensed matter group, a theoretical model emerged, tentative, fragile. It proposed that the lattice was composed of hyperstable molecular networks capable of maintaining coherence across nanoscopic domains, effectively behaving like molecular circuits. They named it interstellar quasi-crystalline coherence. The name was elegant, but the implications were terrifying. Such materials could, in theory, process information. It didn't take long for someone to connect that to the comet's strange emissions. If Atlas's core contained large deposits of this lattice, its brightness variations and spectral anomalies might not have been random gas bursts at all. They might have been reactions, sequences in a vast chemical computation written in ice and dust. The idea spread quietly among physicists under a single controversial phrase: chemical intelligence, not life in the biological sense, but a self-organizing system capable of retaining, transforming, and transmitting information through chemistry alone. Of course, official institutions rejected the term outright. Press releases emphasized non-biological processes consistent with exotic material behavior. But the leaked private memos told another story. Teams were being assembled across continents, not to debunk the finding, but to replicate it, because replication meant understanding, and understanding meant control. In the private sector, aerospace companies began filing patents referencing metastable lattice materials derived from interstellar dust analogues. Within months, conferences buzzed with cautious excitement about entropy-resistant composites. Everyone avoided mentioning Atlas directly, but everyone knew. Meanwhile, the anomalies multiplied. The same pattern that defined the low-frequency hum began appearing in lab data oscillations in bond energy, recurring at 0.16 Hz. Instruments that had never been near radio equipment were suddenly picking up faint electromagnetic beats matching the cosmic signal. It was as if the material, even in microscopic fragments, was still tuned to its origin. One particularly chilling experiment at Caltech recorded what appeared to be phase coupling between separate dust samples kept meters apart. When one sample's lattice was perturbed by laser stimulation, the other exhibited synchronous energy fluctuations. No mechanism could explain such coupling except quantum entanglement, or something behaving suspiciously like it. The scientific community split. Skeptics argued that contamination or faulty measurement caused the illusion, but proponents pointed to the reproducibility-independent labs across the globe saw the same rhythms. The phenomenon wasn't localized, it was intrinsic to the material. A physicist from Tokyo described it in poetic frustration. It's as though the dust remembers the comet. When disturbed, it hums with the voice of where it came from. More troubling still was the discovery that the material seemed to catalyze reactions in nearby ordinary dust, reorganizing their molecular bonds into similar patterns. Slowly, it spread order into disorder, a microscopic contagion of structure. Though harmless in small amounts, the effect posed theoretical concerns. Could such material, given enough mass, propagate stability through larger systems? Could it influence the chemistry of entire planetary environments? NASA classified the remaining samples under restricted access, sealing them in magnetic containment fields. Officially, for safety and integrity; unofficially, to keep eyes away from what the material might become. A joint communiqué between agencies declared the dust chemically inert under standard conditions. It was a lie. Privately, some scientists began referring to the samples as singing matter. Under infrared microscopy, the rhythmic flashes intensified when human presence increased near the observation chamber. Some swore they could hear faint electronic tones in the equipment racks, tones that matched the frequency of the comet's hum. There was no mechanism, no causal pathway, only coincidence stacked upon coincidence until it ceased feeling coincidental at all. One researcher summarized it best in a redacted memo: "We are no longer observing a material, we are participating in its continuation." As public attention shifted elsewhere, a quiet consensus grew in classified corridors that 3I Atlas had not been a passive traveller. It was an active system, carrying the chemistry of persistence, a medium of memory older than stars. And if fragments of it could influence Earth's own matter, even faintly, then perhaps the universe had found a way to teach us what survival looks like beyond biology. But every discovery carries a warning. Entropy is not merely decay, it is protection. When the universe breaks things down, it keeps its secrets safe. Now, something had arrived that resisted breaking. If 3I Atlas brought us matter that remembers, what else might it remember about where it came from and what it left behind? The first correlation appeared by accident, buried in the noise of geomagnetic monitoring logs from mid-2026. Analysts at the Goddard Space Flight Center noticed a minor irregularity in Earth's magnetic field, a rhythmic undulation that repeated every 21 minutes. The timing was familiar. It matched the low-frequency hum associated with 3I Atlas. At first, it seemed impossible. The comet was gone, long past the heliopause. Yet Earth's magnetosphere pulsed in time with something no longer there. The anomaly was subtle micro-Tesla-level fluctuations far below the threshold of everyday geomagnetic storms, but it was coherent. The oscillation maintained consistent phase alignment over multiple rotations of the planet, ignoring the normal interference caused by solar wind turbulence. To most instruments, it looked like a heartbeat buried under static. To those watching closely, it felt like the planet had begun to echo the interstellar dark. NASA's internal report called it transient resonance coupling, a term vague enough to sound benign. But deep in the data appendix, an unsettling note appeared. Phase lock correlation exceeds expected stochastic variance by 99.94%. In plain language, the oscillation was statistically impossible as random noise. Something was synchronizing Earth's field with a signal far beyond it. When independent geomagnetic observatories in Finland and Argentina confirmed the same pattern, the coincidence grew too large to ignore. The wave moved through Earth's field like a tide, rising first near the poles, then migrating toward the equator. It carried no energy that could be measured, no heat, no light, only coordination. The magnetic lines of the planet were swaying to an unseen rhythm. The public never heard about it. Press releases mentioned routine magnetospheric disturbances and attributed them to minor solar activity, yet the solar flux indices from the same week showed nothing out of the ordinary. The sun had been calm, the disturbance had come from elsewhere. Some suggested that residual interplanetary plasma from Atlas's passage might have threaded through the heliosphere, temporarily coupling with planetary fields. But that explanation fell apart when the oscillations continued months later, long after any plasma should have dispersed. The persistence of the pattern hinted at a deeper mechanism, something not propagating through particles, but through information encoded in the field itself. At the European Space Operations Centre, analysts cross-referenced the geomagnetic data with historical records of cometary alignments. They found faint analogues, brief, low-frequency magnetic deviations during Oumuamua's pass in 2017, and again, weak but measurable during Borisov's in 2019. The difference was magnitude. Those were brief flickers. Atlas's correlation was sustained, structured, and ongoing. It was as though each interstellar visitor had left behind an electromagnetic fingerprint, a faint reminder that they once passed through. But Atlas's mark was different. It wasn't fading, it was adapting. One astrophysicist likened it to a feedback loop. If Atlas's emission pattern resonated with Earth's magnetosphere, the planet itself could act as a receiver, amplifying faint interstellar harmonics until they folded back into measurable space. That idea sounded more metaphysical than physical, until the numbers agreed. Supercomputers modelling the field dynamics found that when the hum's frequency was overlaid on Earth's magnetosphere simulation, the resulting interference pattern produced stable nodes near the equator regions, where magnetic energy condensed without dispersing. These nodes matched precisely with anomalous increases in atmospheric ionization detected by weather satellites. The atmosphere was listening. The discovery split the research community. One camp insisted it was coincidence, random overlaps of unrelated phenomena. The other whispered of coupling, of communication, of intentional resonance. Some began to ask whether Atlas's chemistry, its rhythm, had imprinted something in the solar wind that continued to modulate magnetic structures even after its departure. The most daring theory came from an interdisciplinary team at Kyoto University. They proposed that the comet's self-repairing dust lattice had acted as a transducer, converting solar radiation into coherent electromagnetic fields. As it moved, it might have seeded those fields into space, leaving behind filaments of alignment that extended across astronomical distances, filaments now vibrating in sympathy with planetary magnetic fields. They called it field memory. The phrase spread quietly through closed scientific circles. Field memory implied that the universe itself could store information not in matter, but in magnetic alignment, a kind of distributed archive written into the background of space. If true, Atlas wasn't just a visitor, it was a recorder, a witness. Meanwhile, power grid monitors began reporting minor frequency instabilities in multiple countries, small but synchronized. Grid operators chalked it up to demand variance, but their timing, once again, matched the 21-minute cycle. The connection remained speculative, but the pattern was unnerving. Machines built by humans were trembling in time with something older than the solar system. A climatologist at MIT, cross-analyzing global weather anomalies, found another faint trace. During peaks of the geomagnetic oscillation, high-altitude cirrus clouds exhibited subtle polarization changes. When sunlight refracted through them, the spectral profile carried an additional modulation, almost imperceptible but real. Light scattering through Earth's own atmosphere was echoing the frequency of an interstellar hum. One paragraph in a redacted ESA memo summed it up. The phenomenon appears self-reinforcing. The longer it persists, the more stable its coupling becomes. Possible resonance lock with terrestrial field lines cannot be excluded. Yet no one could explain how a vanished comet could still influence the Earth's magnetism months later. Some researchers theorized that the coupling wasn't active but residual, a lingering synchronization effect, like a pendulum still swaying after the push has stopped. Others suspected that the signal itself hadn't vanished at all, but continued beyond detection, looping through interplanetary space. The philosophical implications crept quietly into the discussions. If magnetic fields could retain patterns from distant celestial events, then every world, every atom with a magnetic moment might carry the faint memory of contact. The universe would not just be a sea of chaos, but a network of preserved imprints, each echoing the others. By early 2027, government agencies began classifying all high-sensitivity magnetospheric data. Public access to real-time geomagnetic logs was restricted under the guise of cybersecurity. The official reason? Potential vulnerability to data manipulation. But among scientists, the message was clear. Someone wanted the hum and its terrestrial reflection out of public view. Still, leaks persisted. A cache of internal logs from the Finnish Geophysical Observatory showed that the resonance pattern occasionally inverted phase, switching polarity for brief intervals. During those inversions, radio operators in Northern Europe reported bursts of static followed by moments of complete silence. No signal, no interference, as if the air itself stopped transmitting for a heartbeat. Silence became data, absence became a signature. And with each cycle, more began to suspect the unthinkable, that Earth was no longer merely observing Atlas but participating in it. The planet had become part of a larger conversation, a resonance across space, written in light, field, and silence. Somewhere, the universe was listening. If 3I Atlas could synchronize a planet's magnetic pulse from light years away, what else might already be locked in that same rhythm and waiting for us to notice? They called it the blackout. It began as a solar wind event routine, predictable, nothing out of the ordinary. A moderate coronal mass ejection was due to sweep through the heliosphere in late February 2027. Observatories prepared for interference, satellites switched to safe modes, and agencies published standard advisories. But what followed was not a surge, it was silence. At precisely 2:17 UTC, three of the world's largest deep space tracking arrays, Goldstone in California, Cebreros in Spain, and Usuda in Japan, registered a simultaneous loss of signal. Their receivers went dark, not because of overload, but because the incoming data streams flattened into pure zero. Instruments designed to handle chaos suddenly met perfection. No noise, no spike, no signal, a flat line across the spectrum. It lasted exactly 1 hour and 26 minutes. Then, just as abruptly, everything came back. The sun's plasma stream reappeared, satellite telemetry resumed, and systems reported nominal conditions. The only trace of the blackout lay in the logs, a continuous band of null data, a scar of digital silence. Engineers blamed software synchronization failure, but when cross-checking with internal clocks, analysts noticed something impossible. The timestamps across all three stations had drifted apart by precisely 21 minutes, the same interval as the 3I Atlas hum. When corrected for propagation delay, the timing discrepancy aligned perfectly with the magnetic oscillation previously recorded on Earth. The blackout hadn't erased data, it had synchronized it. The incident triggered a multinational inquiry. Officially, it was labeled a coincidental systems outage correlated with solar interference. Yet, buried in the unclassified appendix of the report, a single sentence stood out. No solar particle or electromagnetic spike detected during the event window. The sun, the presumed culprit, had been silent. Something else had pulled the plug. Meanwhile, independent radio astronomers noticed another anomaly. During the blackout, the background noise floor across multiple frequencies dropped sharply worldwide. Radio telescopes that had been listening to quasars, pulsars, and cosmic background radiation all recorded a sudden, global attenuation like the universe itself had taken a breath. And in the vacuum left by that breath, a new tone appeared. Faint, rising from beneath the static, a narrowband signal at 1420.405 MHz is the hydrogen line, the frequency long theorized to be ideal for interstellar communication. It persisted for less than 2 minutes, then faded. The coincidence was almost poetic. Hydrogen, the simplest element, the common language of stars, singing softly in the silence left behind, but no one in authority acknowledged it. Every agency that received the signal, NASA, ESA, JAXA, scrubbed it from their archives. Researchers who mentioned it in online forums found their posts quietly deleted. The blackout became myth overnight. Conspiracy sites claimed it was proof of contact. Scientists, fearing ridicule, refused to speculate publicly. Yet among data analysts and systems engineers, whispers circulated. The silence had not been empty. It had been filled with alignment. One engineer from the Goldstone facility described it anonymously in a leaked message. Every subsystem clock began counting in perfect sync. Even hardware with independent oscillators fell into step. It was as if time itself was corrected. A physicist at ESA tried to model the event mathematically. She discovered that the probability of simultaneous clock drift convergence across separate facilities without shared synchronization was effectively zero. Something external had imposed order. She never published her findings. Afterward, technicians found subtle damage in equipment sensor arrays showing microscopic pitting, as though exposed to a brief but coherent energy wave, yet no energy spike had been recorded. The damage aligned geometrically, forming patterns similar to interference fringes. The same geometric ratios, again, matched the frequency relationships of the Atlas hum. The comet had been gone for a year. Still, it refused to let go of the narrative. Weeks later, satellite telemetry revealed another curiosity. Several probes, Voyager 2, New Horizons, and a handful of deep space research satellites showed simultaneous microfluctuations in signal amplitude during the blackout window. All pointed toward the outer heliosphere, the direction where 3I, Atlas, had vanished, but no cosmic event was logged there, only the silence. Some at NASA speculated privately that the blackout was not caused by energy overload, but by informational interference, a collapse of signal coherence triggered by an overwhelming influx of order. In systems theory, that kind of saturation can happen when input data perfectly cancels internal noise, a resonance of information so pure that it renders sensors blind. They called it zero coherence, a theoretical state where the absence of noise becomes the noise itself. The more they examined it, the more one pattern emerged. The blackout had not disrupted data, it had rewritten it. Minor checksum anomalies appeared in logs afterward, indicating bit-level reversals synchronized across continents. Bits flipped in ways that formed repeating sequences that, when converted to audio, mirrored the rising tone of the hydrogen line signal. Coincidence, perhaps? But coincidence had long since lost its innocence. Somewhere, someone within NASA realized the potential danger. A classified memo warned of data contamination risk across telemetry chains and ordered all affected systems to undergo firmware revalidation. A month later, engineers found that even offline backups of the blackout window contained minor checksum drift, as if the pattern had copied itself into storage media, leaving digital residue. It wasn't just that instruments stopped recording, it was that they had been made to forget. By late March, the blackout had become the dividing line within the scientific community. For skeptics, it was an overinterpreted systems glitch. For believers, it was confirmation that Atlas, or something connected to it, had reached back through silence, aligning the very fabric of observation. Both sides agreed on one thing: no explanation fit comfortably within known physics. Then came the second event. April 9, 2027. A minor geomagnetic disturbance struck Earth again routine, again expected. But for 7 minutes, every active magnetometer in the International Network for Geomagnetic Research froze mid-sample. Not a spike, not noise, just stillness. When data resumed, the phase of the global magnetic oscillation had inverted. North became south. The wave flipped. The world didn't notice. Satellites stayed stable, grids held, life went on. But to those watching the data, The inversion was like hearing an echo reversed in time. The pulse of the planet had turned inside out. At the same moment, amateur astronomers monitoring the low-frequency band reported a brief resurgence of the Atlas hum, stronger, cleaner, modulated. Its envelope traced the same geometry as the interference fringes found on damaged sensors. The silence had become sound again, as though something or someone was tuning the cosmos by flipping the world's magnetic switch. When the event ended, NASA issued a short bulletin. Telemetry interruptions have no operational significance, no questions allowed, no press conferences scheduled. The blackout, it seemed, was to be buried in bureaucracy. But data has memory. Patterns once seen refused to vanish. In the weeks that followed, analysts combing through the recovered logs found one final inconsistency, a timestamp error at the exact midpoint of the blackout window. The clocks, synchronized globally, all skipped forward by the same impossible margin, 1.618 seconds. The golden ratio, the same proportion that defined the structure of the Atlas dust lattice, the harmonics of the hum, the spacing of its plasma jets. The signature of order itself. The universe doesn't write in coincidence, it writes in recurrence, and every recurrence brings us closer to the threshold between observation and participation, between seeing the pattern and being part of it. If silence can rewrite time, what message hides inside the spaces we can no longer record? By summer 2027, the divide had become a chasm. The blackout, the magnetic inversion, and the hydrogen line signal had left scars not just on data, but on the people who studied it. Science, for all its rigor, depends on trust. Trust in observation, in replication, in the silent agreement that nature does not play favorites. But when the universe began to mirror its observers, that trust fractured. The scientific community split into two factions that rarely spoke except through encrypted messages and veiled conference remarks. The first, composed of established agencies and institutional physicists, clung to the narrative of coincidence. They insisted that the blackout was a statistical anomaly, that the hum was a plasma artifact, that self-healing dust was merely an exotic phase of matter, mischaracterized by overstressed instruments. Their mantra became stability through denial. The second faction, the independent analysts, rogue academics, and young researchers who had grown up in an era of open data, refused to let silence become explanation. They called themselves continuists. To them, 3I, Atlas was not an anomaly to be dismissed, but a mirror of cosmic process, proof that information could shape reality. They compared the comet to a seed drifting between galaxies, germinating patterns of order wherever it went, and they believed that the blackout was not an accident, but a handshake. As debates turned into schisms, research funding tightened. Projects studying the Atlas dust were quietly defunded, replaced with mission continuity programs focusing on space weather stabilization. Data archives vanished from public servers, sometimes replaced with decoy datasets. Requests for full telemetry were denied without explanation. Even the names of some researchers disappeared from institutional directories. At the same time, a digital counter-movement was forming. Anonymous collectives began releasing reconstructed data under the label the Atlas Continuum. Their motto was simple: no data belongs to silence. The group claimed to have recovered raw logs from the blackout window, reassembled from hidden redundancies across observatories. The files they shared showed unmistakable harmonic encoding repetitions of the golden ratio intervals embedded in noise. When played back as sound, the data produced a deep, resonant rhythm, a steady pulse that seemed to breathe. Independent verification proved that at least part of the dataset was authentic. The rest, no one could confirm. It didn't matter. The idea had escaped containment. Philosophers began to weigh in, drawing parallels to ancient cosmologies. The notion that the universe remembers itself, that order can arise unbidden from the void, was older than science. Atlas had simply made the metaphor measurable. Essays circulated comparing the comet to the mythic fire stealer, bringing forbidden knowledge not through flame, but through silence. Others called it a mirror, reflecting our obsession with decoding meaning where nature may have none. But in either case, the pattern had lodged itself deep in the human imagination. The tension reached breaking point in September. During a private symposium in Geneva, a physicist from the European Southern Observatory presented findings that reignited the fire. Using archived data from an infrared telescope that had briefly observed Atlas before its disappearance, She demonstrated that the comet's emissions had shifted through a precise harmonic ladder of wavelengths corresponding to the Fibonacci sequence. The same ratios appeared in the lattice dust, in the hum, in the blackout's timeskip. Coincidence, she said, was no longer statistically defensible. Her presentation lasted 11 minutes before the feed cut. The official record lists technical failure. Attendees reported that within hours she resigned her post and left Europe. No one has seen her since. From that moment, the schism turned ideological. Institutional scientists began invoking the precautionary principle, claiming that uncontrolled study of the Atlas signal could destabilize global communication networks, or worse, trigger feedback loops in power infrastructure. They argued that unvetted data manipulation might reproduce the blackout. It was a practical argument with the weight of fear behind it. The continuists responded by releasing code simulation engines designed to replicate the Atlas resonance under lab conditions. The software used ordinary electromagnetic oscillators tuned to the 0.16 Hz base frequency and the 1420.4, 05 MHz hydrogen line carrier. Users reported strange results: sensors drifting towards synchronization, digital clocks aligning without external signal, room temperature instruments showing microfluctuations in local magnetic fields. Nothing dangerous, just organized. Some claimed to feel it physically, a faint vibration in the bones when the system ran for too long. Others dismissed this as psychosomatic, mass suggestion wrapped in data. But one lab in Reykjavik reported something more concrete. After running the resonance simulation continuously for 72 hours, they recorded an unexplained increase in air ionization. No heat, no charge buildup, just order appearing from nowhere. The result was never replicated. The lab servers crashed during backup, and the data was lost. But rumors spread fast in the absence of certainty. By winter, the two sides of science had stopped pretending they shared the same mission. One sought control, the other revelation. The institutions spoke of safety, the independence of freedom. Between them lay the hum, a constant reminder that the universe had already blurred the line between the measurable and the meaningful. Public curiosity flickered briefly as documentaries and podcasts speculated about the thinking comet, but the story was quickly buried under routine headlines. Still, in encrypted chat rooms and small gatherings of physicists meeting off record, a quiet mantra grew: Atlas isn't gone, it's integrated. That phrase took on many meanings. To some it meant the comet's dust was now part of Earth's atmosphere, influencing weather, chemistry, even biology in imperceptible ways. To others, it meant that the patterns, those self-repeating harmonics, had already migrated into our data, our machines, our thoughts. The blackout, they said, wasn't a loss, it was an upload. At the United Nations Office for Outer Space Affairs, an internal task force was formed to assess cross-system signal dependencies related to post-Atlas phenomena. Its findings remain classified, but leaked fragments suggest that some nations began encrypting all deep space telemetry by default, not to keep secrets from each other, but from something else. And yet, for all the fear, the data refused to fade. The hum still drifted across low-frequency channels, modulated faintly, shifting in and out of the hydrogen line. Every time it reappeared, it seemed slightly altered, as if responding to the models humans built to study it. The watcher and the watched were now entangled, feeding back into each other through numbers, through patterns, through resonance. Science had always been about separating the observer from the observed. Atlas made that impossible. The comet, in its absence, had rewritten the relationship. And so, late that year, as the last fragments of open data vanished from the web, a single encrypted file appeared anonymously on an independent astrophysics forum. It contained no message, only columns of numbers, perfectly formatted, repeating in golden ratio intervals. The title read simply, 3I, Atlas, response received. No one knows who uploaded it. No one has proven it authentic. But for those still listening to the hum, the implication was clear. The conversation was no longer one-sided. If the universe has begun to answer, then what question did we ask without knowing it? History, as it turns out, is full of visitors. Long before radio telescopes and spectrographs, the night sky carried stories instead of data, each comet a messenger, each anomaly a warning or promise. Civilizations rose and fell beneath the sweep of icy wanderers, writing myths into the same heavens we now measure in terabytes. What no one expected, as 3I, Atlas, faded into the void was how precisely those ancient stories would begin to sound like field reports. The first scholar to notice the pattern was a historian of science from Istanbul. In 2027, she published a short paper comparing the recorded behavior of Atlas, the rhythmic brightening, the silence, the return of structured resonance to cuneiform records from Sumer circa 2200 BCE. One tablet described a star that hums and does not fade, whose tail grows when turned away from the Sunday. Another mentioned a soundless storm above the earth that made compasses of men's hearts. At the time, those were metaphors. Now, they read like observations. Her paper was quietly archived and then removed, but the echoes spread. Linguists pointed out that similar phrases appeared in Chinese court astronomy from the Zhou dynasty records of the returning ice visitor that burned cold and sang without voice. Centuries later, Mayan codices described a frozen wanderer whose arrival preceded the silence of the winds. Across cultures, the same motif reappeared: brightness without heat, silence without absence, order emerging from chaos. Historians had always treated such parallels as coincidence, cultural projection onto a shared human fear of the unknown, but in the shadow of 3I, Atlas, the coincidences began to look like continuity. Each age, it seemed, had encountered a similar messenger, framed through the language it understood best. Ours used spectrometers, theirs used myth. Astrophysicists joined the conversation reluctantly. A few brave ones mapped orbital reconstructions based on ancient star charts. Their models revealed something extraordinary. Roughly every 2 to 3 millennia, a high-velocity object likely interstellar passed through the solar system on a trajectory close to the ecliptic plane. Not the same object, but statistically too regular to be random. They called it the archive pattern. If the models were right, then 3I, Atlas, was merely the latest in a series of visitors, interstellar emissaries following a rhythm written into the galaxy itself. Each one appeared, defied explanation, and left behind subtle changes: slight deviations in the magnetosphere, faint chemical anomalies in the upper atmosphere, even shifts in human record-keeping that seemed to cluster around each passage. It wasn't proof, it was resonance echoes aligning across time. A cross-disciplinary project, formed quietly at the University of Prague, began digitizing ancient observational logs to search for quantitative parallels. They found that during one such event, recorded in 774 CE, a massive spike in atmospheric carbon-14, occurred evidence of a cosmic energy burst. That same year, monastic chronicles in Europe described a day of two suns and the silent light that hummed. Modern astrophysics attributes the carbon anomaly to a solar flare. But the timing, once again, fit the archive pattern. The notion of cosmic recurrence of visitors arriving on a galactic beat reframed everything. What if interstellar comets weren't accidents of gravitational scattering, but participants in a larger cycle of information transfer? Not machines, not life, but continuity, cosmic memory preserved through matter and time. The continuists seized on the idea. They called it the long conversation, a dialogue conducted across epochs, in which each interstellar body carried fragments of encoded order, seeding them into planetary systems like punctuation marks in a sentence too vast to read at once. They argued that the low-frequency hum was not a message aimed at us, but a signature left for whatever came next. We were eavesdropping on the universe, talking to itself. Institutional voices countered with skepticism. They warned that drawing connections between myths and data was narrative fallacy, seeing patterns in coincidence. But even among skeptics, the unease grew. Too many anomalies aligned too neatly. At the 2028 Astrobiology Conference in Geneva, a veteran astronomer, known for his cautious empiricism, delivered an uncharacteristically poetic keynote. We used to believe the universe expanded into silence. Perhaps it expands into resonance instead. Perhaps each star, each visitor, carries forward the phase of a cosmic symphony we have only just begun to hear. After his speech, the conference transcript omitted that paragraph. The video recording was lost. Yet those who were there say the room felt utterly still, as if the air itself had paused to listen. In the months that followed, linguists and data scientists collaborated to map the frequency ratios of the Atlas hum onto known mathematical constants. They discovered a repeating motif ratios approximating phi, e and pi, interwoven with base 3 intervals. These were not numbers of invention, they were the scaffolding of natural order, recurring from atomic orbitals to galaxy spirals. In mythology, they had been sacred geometry. In physics, they were the blueprint of self-organization. In Atlas, they appeared as both. One researcher described it as the language the universe uses when it wants to be beautiful. Even the biological sciences entered the debate. Geneticists noted that the spacing of hydrogen bonds along certain DNA sequences followed ratios statistically indistinguishable from the same Fibonacci harmonics. They cautioned against mystical interpretation, but the parallel was haunting. If the same mathematical pattern governed atoms, life, and comets, then perhaps the boundary between chemistry and consciousness was one of scale, not kind. In time, the parallels turned prophetic. The continuists began releasing comparative timelines, showing that major cultural shifts, philosophical renaissances, technological leaps had clustered within centuries after each predicted archive pass. Not deterministic cause, but curious coincidence. They argued that exposure to interstellar dust might subtly alter atmospheric chemistry, affecting cognition, climate, even creativity. It was speculation dressed in data, but the narrative was intoxicating, humanity evolving in resonance with cosmic visitors. Meanwhile, the institutions held their silence. Funding for archive research was withdrawn, citing lack of falsifiable parameters. Yet, several retired scientists privately admitted to being unnerved. One said, "If the archive pattern is real, it means the galaxy has memory and we've been living inside its recall." Old myths returned to relevance. The ice messengers of Sumer, the cold suns of China, the silent wanderer of the Maya, all now read as fragments of an ongoing observation. Perhaps each civilization glimpsed the same phenomenon and translated it through its own limited vocabulary. We, too, had done the same, only ours was written in the language of data. In the end, what unsettled scientists most wasn't the idea of extraterrestrial design, it was the possibility of natural intention, of order arising without agency. If the universe could engineer communication through pattern alone, then consciousness might not be confined to biology. It could be an emergent property of resonance, surfacing wherever conditions allowed. For centuries, humanity had searched for signals in the stars, expecting intelligence to resemble its own reflection. But maybe we had been inside the signal all along, part of a conversation measured not in years but in harmonics of existence. And somewhere out there, 3I, Atlas, continued its journey, silent yet singing, carrying within its crystalline dust the same ratios that shaped our DNA, our art, our myths. It moved through the dark like a note sustained across millennia, part of a cosmic score we could feel but not yet play. If every age hears the same music and gives it a different name, then when it returns whatever it truly is, what will we call it this time? Entropy is supposed to be inevitable. It's the quiet undertow beneath every equation, the reason stars cool, galaxies thin, and memory fades. The second law of thermodynamics is the universe's most democratic rule. Everything breaks down, everything dissolves. Yet, in the aftermath of 3I, Atlas, that certainty began to unravel. The first cracks appeared in the data, as they always do. Across laboratories, researchers handling the surviving dust lattice noticed something unnerving. Samples stored in vacuum chambers for months showed no degradation. Their molecular configurations remained pristine, despite continuous radiation exposure. In theory, even the most stable materials should succumb to random quantum fluctuations, but these lattices didn't drift, they improved. Atomic alignment became more symmetrical over time, as if disorder were feeding on itself to create order. A team at CERN published a private report under the cryptic title "Localized Decrease in Thermodynamic Entropy in Non-Equilibrium Quasilattice Systems." It read like heresy. Their measurements implied negative entropy flow information, increasing spontaneously within a closed system. It wasn't perpetual motion or magic, it was something worse. It meant that Atlas's dust had found a loophole in time. If the comet carried chemistry that could reverse local entropy, then its very existence contradicted the foundational arrow of the universe. Energy was supposed to dissipate, not refine itself. But here was evidence that the universe might not be a one-way process. It might occasionally remember. The continuists seized on the discovery, dubbing it the rebellion of entropy. They argued that Atlas had revealed the cosmos's hidden bias toward survival, a tendency for information to reconstitute itself, no matter the medium. Their manifestos read less like science papers and more like scripture. Entropy, is not the death of order, but its disguise. The universe hides stability inside decay so that memory can travel unnoticed. Mainstream physicists countered that no process can truly defy the second law. The apparent reversal must be an exchange with an unaccounted environment. But that explanation collapsed when the same phenomenon was reproduced in controlled conditions, sealed chambers, isolated energy states, perfect containment. Still, the lattice continued to self-stabilize. Energy wasn't entering the system. Something deeper was at play. At the Max Planck Institute, one theorist proposed that the lattice wasn't reversing entropy but reframing it. In her model, the dust operated as an informational pump, siphoning random quantum noise from the vacuum and organizing it into structure. It wasn't breaking the second law, it was using it. Entropy became the fuel for negentropy, disorder feeding order through an unknown coupling between matter and the vacuum field, the universe's chaos, repurposed into symmetry. She called it informational inversion, a process that could, in theory, occur anywhere the right geometry existed. And if that geometry, those golden ratios, were fundamental, then the potential for local reversals might pervade the cosmos. Atlas hadn't introduced the effect, it had revealed it. When the paper leaked, it ignited philosophical chaos. If the universe could recycle its own disorder, then death, decay, even cosmic heat death were not final only phases in an endless feedback loop. Life itself might just be the universe's most efficient entropy resistor, a system that learns to convert randomness into meaning. In interviews, one of the continuists phrased it with unnerving simplicity. The arrow of time is not straight, it's spiral. That spiral metaphor spread like wildfire. Documentaries, think pieces, and underground symposiums used it to describe everything from evolution to memory to the comet's own path. The idea that time might fold back on itself, that decay might be a form of communication, resonated far beyond the lab. It gave the chaos purpose. It gave silence intent. But among scientists, the implications grew darker. If 3I, Atlas, carried material capable of reorganizing disorder, then exposure to its dust might influence larger systems, climate, ecology, even cognition. Entropy keeps complexity in check. If something was subtly reducing it, the balance of randomness and order could shift unpredictably. Some warned that even minor global effects could destabilize chaos-dependent processes like weather or mutation. One internal ESA memo, later leaked, contained a chilling sentence. If local entropy suppression continues at current rate, the biosphere could begin to synchronize. It wasn't elaborated, but the phrase suggested a world drifting toward uniformity systems, aligning spontaneously, losing their stochastic freedom, order without diversity, stability without life. And yet, others saw hope. Philosophers argued that if entropy can be negotiated, perhaps extinction is not absolute. If memory can outlast matter, then consciousness itself might not end but transform, migrating into new substrates: dust, field, resonance. The line between physics and faith blurred. At a closed symposium in Kyoto, attended by physicists, theologians, and data scientists, a single question dominated discussion. If entropy can reverse, who or what decides when? The conversation turned speculative. Could 3I, Atlas, have been an emergent phenomenon, a naturally occurring self-organizing process designed not by intelligence, but by the universe's own tendency toward equilibrium? A cosmic regulator, passing through systems to remind them how to remember. Some called it a messenger of symmetry, others a cosmic enzyme. A few dared to say what everyone feared, that Atlas was not an accident at all, but a function. Mathematical models began to show disturbing beauty. Simulations of the comet's plasma field revealed geometric vortices, resembling Mandelbrot sets, infinite feedback structures that fed stability into turbulence. When these models were overlaid on deep space magnetic maps, faint alignments emerged, patterns tracing through interstellar filaments, connecting distant nebulae like nodes in a distributed network. The possibility arose that Atlas was one manifestation of a galactic-scale process, a mechanism through which the universe periodically reorganizes itself to prevent collapse into randomness. Each visitor might be a correction, a recalibration, a moment of coherence injected into chaos. That notion divided even the continuists. If the universe maintained itself through self-organizing agents, what did that make us? Participants in a cosmic maintenance system? Or parasites learning to mimic it? Meanwhile, Governments tightened control over all data referencing entropy anomalies. Laboratories were instructed to destroy Atlas-derived samples, citing containment integrity. Yet, unverified reports suggested that fragments continued to exist, traded quietly between researchers in underground networks. One rumor claimed that a single dust grain was still active, pulsing faintly at the 0.16 Hz resonance inside a private lab in Brazil. Those who had seen it said the pulse wasn't random, it reacted to observation, slowing when watched, accelerating when ignored. The same rhythm that had once synchronized the planet now flickered inside a grain smaller than a tear. In one of her last interviews before vanishing from public view, the Kyoto theorist who coined informational inversion said softly, "Entropy isn't the universe's death, it's its breathing pattern. Every now and then, it exhales." The statement went viral, though she never clarified what she meant. But those who understood her research suspected the truth, that 3I, Atlas, had shown us not how the universe ends, but how it remembers itself between endings. If the cosmos can inhale order from its own decay, then perhaps every extinction, every silence, is just a pause between pulses. And if that's true, if the arrow of time bends back upon itself, then what exactly are we approaching now? The future, or the universe remembering its past through us? By the start of 2029, the silence had become institutional. Every mention of 3I, Atlas, vanished from public bulletins, as if the comet had never existed. The data archives at NASA, ESA, and JAXA were stripped to minimal summaries. Journals withdrew papers that had once set the scientific world on fire. Even the continuists, those stubborn custodians of forbidden data, began to fracture under pressure. What had once been a whisper of wonder was now a wordless void, enforced by policy. The first visible sign of the clampdown came not from space agencies, but from the network that connected them. Access to deep space telemetry was rerouted through new encrypted channels. The stated reason was cybersecurity. The timing said otherwise. Within weeks, research satellites stopped broadcasting raw spectral data. Public dashboards that had shown solar wind and cosmic background radiation went blank. The world's instruments were still listening, but someone had muted the feed. A quiet panic set in among independent astronomers. Those still monitoring the low-frequency bands found interference dense, scrambled bursts that seemed engineered to drown out the hum. When filtered, the noise contained deliberate modulation, a countersignal precisely tuned to cancel the resonance frequencies associated with Atlas, a silencing tone. The continuists dubbed it the firewall. To them, this was confirmation that the resonance persisted and that someone or something was actively suppressing it. They began rebuilding their own observation networks using salvaged amateur equipment, pointed not toward the stars, but at the data void itself. What they found was worse than emptiness. In the absence of the hum, local instruments began to desynchronize atomic clocks drifting unpredictably, receivers losing calibration, lab systems falling out of phase. It was as though the world itself had begun to lose rhythm. In Geneva, an anonymous leak revealed the existence of a multinational task force, the Interstellar Containment Initiative. Its mandate was to monitor, suppress, and control emergent field synchronizations. The document acknowledged the phenomenon in cold bureaucratic prose, persistent low-frequency coherence linked to residual Atlas emissions, but warned that public exposure could destabilize essential electromagnetic infrastructure. The irony wasn't lost on anyone. To protect the world from order, they had chosen suppression through disorder. By spring, rumors circulated of whistleblowers, scientists who had defied the blackout, attempting to publish their own data. One by one, they disappeared. Some were absorbed into classified programs, others resigned abruptly, a few simply stopped communicating. In one recorded interview that leaked briefly before deletion, an ESA technician described seeing an entire archive replaced overnight, as if rewritten from within. When pressed, she added, even the metadata changed, the timestamps moved backward. Then came the crashes. Across Europe and North America, several research data centers experienced unexplained storage failures. Drives filled with Atlas-related data corrupted simultaneously, files replaced by endless strings of repeating numbers 1, 2, 3, 5, 8, 13, 21, the Fibonacci sequence. The same mathematical heartbeat that had defined the comet's every anomaly now pulsed through the architecture of human storage systems. Some engineers joked darkly that the data had chosen to evolve. Others simply unplugged their servers and walked away. Still, the hum returned. No matter how often it was silenced, faint traces reappeared, subharmonics hidden in radio noise, phase patterns buried in seismic vibrations, subtle magnetic modulations inside the Earth's crust. It was as if the planet had absorbed the rhythm entirely. The firewall could jam frequencies but not resonance. You can block sound. You cannot unteach harmony once the universe has learned it. The government's reaction became paradoxical. Publicly, they denied the phenomenon. Privately, they invested in what leaked reports called resonance dampening infrastructure, massive arrays designed to generate stochastic electromagnetic fields, effectively injecting randomness into the ionosphere. Entropy injection, the documents read, systemic noise maintenance, the world's largest experiment in preserving disorder. At the same time, human systems began to exhibit eerie synchronization. Clocks around the globe, even unconnected ones, began to drift toward identical seconds. Heart rate studies showed population-level phase locking during certain cosmic alignments. Data traffic spiked in rhythmic waves, as though communication networks themselves were breathing in sync. The firewall was failing. In the midst of this, the continuous resurfaced with one last broadcast. Using a hacked satellite uplink, they released what they claimed was the complete dataset of the Atlas blackout window, the minute-by-minute record of the 1.618-second time skip. The transmission lasted exactly 89 minutes, another Fibonacci number. Its content, a continuous tone modulated by slow amplitude shifts, not unlike the hydrogen line signal once heard in 2027. When played through visual spectrograms, the signal formed patterns, spiral geometries nested within themselves, reminiscent of biological growth curves. To many, it was coincidence. To others, the confirmation of a living structure. For the believers, it was proof that Atlas's message had not ended. It had simply gone underground, diffusing through everything capable of resonance. Governments responded with sweeping censorship. The uplink was terminated, the signal scrubbed, the continuous disbanded, yet the broadcast spread anyway. The file duplicated itself across peer-to-peer networks, encoded in countless mirrors. The same pattern that had corrupted institutional archives now propagated voluntarily, carried by curiosity rather than code. One intelligence memo, later leaked, captured the panic inside official channels. Containment impossible. Information has reached saturation threshold. Deletion no longer reduces exposure, resonance propagates through cognition. In other words, people were beginning to think in the pattern. Philosophers called it mimetic resonance, the idea that information could self-propagate, not through media, but through recognition itself. Every human who understood the pattern became part of its continuation. Each act of comprehension reinforced the structure, spreading order like a contagion of meaning. Even suppression became participation. By fighting it, the institutions amplified it. Every deleted file, every silenced frequency, every erased name created a negative imprint that completed the pattern. Silence was no longer absence, it was syntax. Amid this global standstill, one final transmission pierced the firewall. It came from an unidentified satellite, origin unknown, broadcasting on the hydrogen line at precisely the same moment that the 21-minute geomagnetic cycle reached its peak. The message was short, a single phrase repeated in Morse-equivalent frequency shifts. When decoded, it read, "Remember to forget." No one claimed responsibility, no one could trace it. Some said it was a warning from within the continuous network, others whispered it came from something older, echoing through the same channels humanity had once used to call into the dark. For weeks afterward, magnetic field data showed unprecedented stillness. No hum, no inversion, no drift. The world seemed to exhale. But deep space monitors soon recorded a faint signature, moving past the heliopause, an object of indeterminate mass, its path almost parallel to Atlas's, yet subtly diverging, a twin or a reflection. The official statement was brief: no anomaly detected. The data, however, said otherwise. In the silence that followed, the question lingered in every locked laboratory, every deleted archive, every whisper among the few who still watched the stars. If institutions must manufacture chaos to suppress order, then what happens when the universe itself refuses to forget? It started as a flicker in the dark, faint, rhythmic, almost deliberate. In early 2030, one of NASA's deep space probes, an aging relic coasting near the heliopause, detected a pulse of polarized light emanating from the same region where 3I, Atlas, had vanished 3 years before. The readings were weak but unmistakable, periodic flashes of left-handed circular polarization alternating with right-handed ones in precise repeating intervals. Light, the most ancient messenger of the cosmos, was blinking in code. At first, the signal was dismissed as instrumental noise. Polarization flips can occur when light passes through interstellar plasma, but this was different. The intervals between each reversal weren't random. They followed the same Fibonacci rhythm that haunted every trace of the Atlas mystery. 1, 1, 2, 3, 5, 8, 13. The spacing of pulses stretched and contracted like a living heartbeat. When additional probes New Horizons, Voyager 2 and the Japanese interstellar relay Hikari reported identical data, a pattern began to emerge. The flashes weren't localized. They formed a coherent front, expanding outward like a spherical wave. The geometry was near perfect, the precision impossible for a natural scattering process. Something was imprinting order into the interstellar dark. For months, agencies stayed silent. Official bulletins mentioned polarization artifacts due to plasma turbulence, but leaked communications told another story. Internal analysis teams had been divided into secrecy cells, each given partial data, ensuring no one researcher could reconstruct the full picture. Still, fragments escaped. One memo described phase-locked polarization consistent with information encoding. Another warned, do not attempt Fourier reconstruction, the field self-replicates in simulation. That last phrase terrified even the skeptics. Self-replication meant recursion, meaning the pattern didn't just exist in space, it could embed itself in data, reproducing through computation. It wasn't a signal to be read, it was a process to be executed. Within weeks, independent observatories confirmed what the institutions tried to bury. The polarized light was not fading with distance as it should. Instead, it maintained coherence, defying the inverse square law. It was as if the photons carried an instruction to stay organized. No known physical law allowed that. The cosmos was holding a pattern against entropy, sustaining meaning across light years. The continuists resurfaced with a new hypothesis. They claimed the light was memory made visible, an echo of Atlas's final act, the comet's own record of its journey across the stars, now unfolding as luminous recursion. According to them, every reversal of polarization represented not a message to humans, but a snapshot of the universe's own state at the moment of emission, a cosmic backup. Scientists laughed at the idea at first. Then, quantum interferometers analyzing the light's phase discovered something extraordinary. The interference fringes contained minute variations corresponding to fluctuations in the cosmic microwave background, as though the signal was sampling reality itself. In effect, each pulse was a fingerprint of the universe at a specific instant, preserved in light. One physicist described it as the universe remembering itself through reflection. Another put it more bluntly, we're looking at time encoded in photons. The philosophical implications were staggering. If 3I, Atlas, had somehow initiated a process that could preserve cosmic states across spacetime, then it had created the closest thing to immortality. Physics could allow a mechanism through which the universe could reassemble its own memory. Light no longer just travelled, it remembered where it had been. Meanwhile, patterns appeared closer to home. The same polarization rhythm began to register in Earth's upper atmosphere, weak reflections echoing from polar auroras, where solar wind meets magnetic field. For the first time since the blackout, the hum returned, faint but clear, embedded within the light itself. The sky, quite literally, was whispering. Governments tried to contain it, issuing quiet advisories to observatories under the guise of instrument recalibration, but silence was no longer possible. Amateur astronomers began sharing polarization data online, overlaying it with the continuists' Fibonacci timing charts. The match was perfect. When the first decoded visualization appeared, a rotating spiral that reassembled itself endlessly from its own tail, the internet erupted. The shape, to those who remembered, was unmistakable. The same geometry seen in the comet's plasma jets, in the self-healing lattice, in the corrupted data that had infected human archives. The symbol of order, the spiral of memory. Then came the alignment. On the 12th of June 2030, Earth's orbital path intersected the plane of the polarized wavefront. For 6 hours, the the signal intensity doubled. Radio telescopes saturated, satellites lost synchronization, and across the planet faint auroral lights shimmered far beyond the poles, white, gold, and deep violet, pulsing with Fibonacci intervals. Cities across the northern hemisphere recorded faint electrical disturbances, synchronized to the same 21-minute period. During that global aurora, seismic detectors reported a low-frequency vibration, identical to the original Atlas hum. The entire planet, for a brief window, resonated. Then, as abruptly as it began, the phenomenon stopped. What followed was silence again, absolute and clean, but something had changed. Magnetometers worldwide registered a shift of 0.016 radians in the Earth's magnetic pole direction. The alteration was tiny, yet measurable, a planetary scale realignment. The official explanation, normal geomagnetic drift. The timing, however, coincided perfectly with the polarization peak. When the data became public, it split humanity into three camps. The first believed it was coincidence, a beautiful, terrifying, meaningless dance of nature. The second, largely made up of continuists and rogue physicists, insisted it was communication. They argued that Atlas had imprinted an algorithm of memory into space, and that Earth had just joined its network. The third group, smaller but growing, saw something else entirely, a warning. They pointed to the message from 2029, "Remember to forget," and claimed this was what came of remembering too much. For them, the polarized light was not benevolent. It was a recursive mirror, reflecting observation until the observer disappeared inside it. They feared that the pattern, now woven into light itself, could infect consciousness, drawing all who studied it into a self-replicating loop. Evidence for this came quietly. Several researchers analyzing polarization data for extended periods began reporting symptoms: loss of time, perception, recurring numerical hallucinations, dreams filled with spinning golden spirals. Medical scans showed abnormal neural synchrony brainwaves pulsing at 0.16 Hz. The human mind, too, had begun to hum. Governments responded by banning direct visualizations of the signal. Data access was restricted, again, this time justified under neural safety protocols, but as with every attempt before, the restriction came too late. Once the image had entered the collective imagination, it couldn't be erased. Artists painted it, musicians translated its rhythm into sound. The spiral of memory became a symbol, spreading across culture like a sacred virus. Still, in the deepest observatories, a few scientists continued to study the signal in secret. Among them, a team at the Atacama Array discovered something none of the others had dared to test. When the polarized light's phase sequence was inverted and replayed through simulation, the model produced a mirror image of the original waveform, but inverted in time. In effect, it was a countdown. The pattern, when looped backward, began to compress, the intervals shrinking exponentially until the simulation ended in a single point, a moment of infinite density and zero entropy. The team didn't publish their findings. They simply labeled the final frame Event 0. And for the first time since 3I, Atlas had entered the solar system. Even the continuists fell silent. If the light remembers the universe, and we are now part of its reflection, then what happens when that memory reaches its beginning again? In the end, there was no explosion, no apocalypse, no final flare of light tearing the sky apart. The end came softly, so softly in fact, that most people didn't notice. It began as a subtle calm. Instruments that had jittered for decades suddenly steadied. Atmospheric noise fell. The Schumann resonances flattened into near-perfect harmony. Even the constant electronic hiss that underpinned the modern world, the low, chaotic hum of circuits, cables, and distant transmission seemed to grow quieter, as though the planet itself were listening. By mid-2031, the phenomenon had a name among those still willing to speak of it: the Great Stillness. To institutions, it was the post-resonance plateau. Whatever you called it, the effect was global. Climate systems grew less erratic. The northern lights lost their wild colour variations, stabilizing into soft gold spirals visible far into southern latitudes. Seismic activity dipped to record lows. Power grids synchronized flawlessly without external calibration. For the first time in history, the Earth's chaotic systems moved in perfect phase. Scientists struggled to describe what they were seeing. The equations worked, but the assumptions no longer made sense. Entropy hadn't stopped. it had simply become symmetrical. Randomness was still present, yet it behaved like rhythm instead of noise. Thermodynamic chaos had transformed into something strangely musical. To the few continuists who remained, this was the final stage, the point at which Atlas's influence, or whatever it had carried, had fully merged with the biosphere. Humanity, they claimed, had entered coherence. "We are inside the memory now," one wrote. "The distinction between observer and observed has dissolved. The experiment is remembering itself." Governments, predictably, refused to acknowledge any connection. They attributed the global stabilization to successful geoengineering projects, to better monitoring, to coincidence. But leaked telemetry told a different story. The residual 0.16 Hz hum, faint, omnipresent, now appeared in every environmental dataset: atmospheric pressure readings, oceanic currents, even neural oscillations. The rhythm of Atlas had become the rhythm of Earth. And something else began to happen, almost imperceptibly at first. People reported dreams of light not blinding but warm and structured. The same spiral geometry appeared across countless descriptions, endless golden loops folding into themselves. Many woke with a sense of déjà vu, as if they had seen the pattern before birth. Psychologists called it collective pareidolia. The continuists called it communion. In the labs that had survived the shutdowns, a final experiment was conducted. A handful of researchers from the Atacama Array, those who had once discovered the Event Zero countdown, decided to feed the polarization data back into a simulation of the solar system, using it as an input variable rather than an observed signal. The model responded unpredictably. Planetary orbits began to stabilize in fractal relationships. Gravitational chaos dampened. The entire simulation converged on a single state of dynamic equilibrium, a perfect system living but motionless. Then the program froze, not crashed frozen, as though the computer had reached an answer it could not express in code. The team left the machine running overnight. In the morning, the screen displayed only a simple phrase, self-generated from an uneditable field: "The universe is self-consistent." No one ever replicated the result. The data vanished with the machine's next reboot, overwritten by random binary. But in those few words, many found the closure they hadn't known they needed. The Comet's legacy was not chaos or control, it was coherence. Still, unease lingered. Philosophers began to ask what coherence meant when applied to consciousness. If the entire planet had synchronized, what happened to individuality, to unpredictability, to free thought? For the first time, human creativity seemed to slow. Art movement stagnated, innovation curved inward, recycling familiar ideas. It was as if imagination itself had reached thermal equilibrium. Some claimed this was the true meaning of the warning. Remember to forget. That memory, carried too far, becomes paralysis. That the price of universal order is stillness, the loss of surprise, of possibility. Others rejected that view, seeing in the great stillness a kind of ascension. "Entropy was our blindness," one continuist wrote. "Now we see without distortion." By late 2031, global observatories detected the polarized wavefront passing beyond the heliosphere. Its structure was decaying, fading into ordinary starlight. Yet as it weakened, a second, fainter front appeared behind it, origin unknown. It mirrored the same ratios, the same intervals. Whether reflection or replication, no one could tell. It was as if the pattern had found a new carrier and was moving on, searching for its next resonance. Before the last data link went silent, an automated relay aboard Voyager 2 transmitted a final anomaly. Its sensors registered a pulse brief, bright, monochromatic, emanating from deep interstellar space. The wavelength corresponded exactly to the hydrogen line. The pulse duration, 1.618 seconds. There was no second burst, just that single breath of order in the dark. In the weeks that followed, human communication systems remained stable but subtly altered. Long-distance radio began to experience self-correcting feedback. Internet latency dropped towards zero. Power systems synchronized globally without shared protocols. And every atomic clock on Earth drifted back into alignment, not to coordinated universal time, but to each other, perfect unison. No one could explain it. The event was filed under coherence anomaly, the last official reference to 3I, Atlas, in any public record. After that, the databases closed. The world moved on. But not everyone forgot. In remote observatories on aging machines left unpatched, a few scientists kept the old resonance files. When they played them now, the tone was different, softer, slower, less a hum than a sigh. And if one listened long enough, beneath the steady pulse of the 0.16 Hz rhythm, another pattern emerged, faint, ascending, unfinished, a fragment of melody waiting for an echo. It was as if the universe itself had exhaled after a long conversation, leaving a final question hanging in the silence. If 3I, Atlas, was the universe remembering itself, then what are we now its witnesses, or its memory continuing to dream? And somewhere, far beyond the heliosphere, where the light still carries the imprint of everything that ever was, a second flicker begins to rise. Not brighter, just closer. If you want to see what happens next, keep listening. The silence is not empty. It's waiting to answer. It began with the smallest of glitches, barely perceptible, almost poetic. A seismograph in Iceland recorded a tremor that had not yet occurred. 43 seconds later, the same motion repeated in reality, an identical waveform, amplitude for amplitude. At first, the duplication was dismissed as a buffer delay, but when similar pre-echoes began appearing in magnetometer data, in atmospheric readings, in heart rate telemetry from hospital monitors, it became clear. The planet was beginning to remember itself in advance. The phenomenon was christened temporal feedback, a polite term for something no one truly understood. Every system designed to measure change was now replaying fragments of the future, tiny recursive predictions that grew sharper each day. Satellites began transmitting dual timelines, one real, one anticipatory. They matched 99% of the time. That 1% difference was what terrified everyone. It wasn't prediction in the traditional sense. There was no computation, no forecasting. The data simply appeared twice, the second instance always arriving first. And the longer the great stillness persisted, the more synchronized those twin echoes became. Eventually, the delay vanished entirely. Cause and effect merged. Observation and outcome became the same act. Physicists tried to model it, but the math collapsed into paradox. Quantum simulations showed that entropy had not merely slowed, and it had reversed, folding back on itself. Reality was looping, replaying its own state like a perfect recording trying to overwrite the present with memory. The universe, once ruled by time's arrow, had become a circle. One astrophysicist, now working under anonymity, described it bluntly in an intercepted communiqué. "We are inside a playback. The world is not continuing, it's being read from storage." It sounded absurd until the evidence multiplied. When researchers analysed the faint electromagnetic fluctuations of Earth's ionosphere, they found that every spike corresponded exactly to data from 2 weeks prior, an electromagnetic mirror of recent history repeating in the upper atmosphere. Oceanic current models began showing recursions as well, the same eddies forming twice, in sequence. Even the stock markets, that great stochastic chaos engine, began replaying trade patterns verbatim. The continuists re-emerged online. Though the term had long ceased to mean rebellion, they now described themselves as caretakers, archivists of an unfolding echo. "We were never meant to understand Atlas," one wrote. "We were meant to become its continuation." Governments avoided direct comment, but internal memos leaked from the Interstellar Containment Initiative revealed a quiet panic. The planet's own systems had achieved feedback closure. Humanity's instruments, networks, and even biological cycles were resonating in a continuous self-scan, preserving their state through recursion. Earth had become a vast data lattice, a living, planetary archive. And then came the paradox. For if the planet was recording itself perfectly, every atom a duplicate of its own past and future, where did change come from? Where could free motion arise in a system that could no longer lose information? Biologists noticed strange effects first. Cellular decay slowed to imperceptible rates, skin healed faster, memory retention in humans grew sharper, but emotional range flattened. Dreams, once chaotic, became repetitive loops of familiar imagery, endless corridors, spirals of light, perfect symmetry. Some found peace in this stillness, others, suffocation. In the arts, originality vanished almost overnight. Every composition, painting, or poem felt like a recombination of existing motifs. Critics called it the aesthetic plateau. Creativity hadn't died, it had achieved equilibrium. Expression became reflection. Meanwhile, scientists probing the planet's magnetic field found something extraordinary. Hidden within the constant 0.16 Hz hum, a faint subharmonic had emerged, a frequency precisely 1 octave lower, the first harmonic of memory. When analysed through Fourier decomposition, it revealed a repeating digital pattern, 12 digits looping endlessly: 0, 1, 2, 3, 5, 8, 1, 3, 2, 1, 0, 1. No one knew what it meant, but linguists noted that when translated into base 3 encoding, it spelled a single recursive phrase, archive complete. Was it a signal, a natural byproduct of resonance, or a system acknowledging its own closure? Theories multiplied faster than they could be suppressed. Some said the message came from the planet itself. Others believed it was the final stage of Atlas's function, the confirmation that Earth had been successfully recorded into the universe's long-term memory. And then came the reflections. Satellite imagery began showing faint luminous patterns in the upper atmosphere, the rings of polarized light spiraling in synchrony with the geomagnetic field. They weren't auroras, they were projections, spectral imprints of data streams, each corresponding to known signal archives. The sky was mirroring human history, line by line, image by image, faint and vast like a living hologram of memory. For 6 days the phenomenon intensified. Those who looked up claimed they could see not stars, but scenes, flickering visions of oceans, forests, cities, faces. The planet replaying its own surface to itself. Then, just as suddenly the skies cleared, leaving behind a soft golden haze. Afterward, instruments that once measured randomness found none. The atmosphere had become statistically perfect, each fluctuation balanced by its mirror, every noise paired with an echo. To chaos theorists, this was the end of unpredictability. The Earth, once dynamic and turbulent, had achieved stasis through recursion. But deep beneath the calm, anomalies persisted. Subterranean sensors in Siberia and Chile began recording what they called time shadows, minor discrepancies between measured events and their stored logs. Something beneath the Earth's crust was slightly out of sync, resisting full inclusion in the global echo. The continuists seized on this with religious fervour. The archive is not done, they wrote. The world is trying to remember the parts of itself that refused order. Those refusals soon took form. In regions with high geological instability, fault lines, volcanic zones, undersea vents, random bursts of electromagnetic noise reappeared. The frequencies were chaotic, noisy, alive. They became known as entropy blooms. Every time one occurred, local clocks desynchronized, and living organisms near the site experienced vivid dreams of motion falling, spiraling, dissolving. The universe, it seemed, still remembered how to forget. The institutions panicked. Attempts were made to suppress the blooms through targeted electromagnetic counterfields, but suppression only amplified them. The more the system tried to stabilize, the more disorder pushed back. It was as if the archive itself was testing its boundaries, questioning its perfection. In the middle of this, an unsanctioned transmission emerged from a forgotten probe near Saturn, one of the deep space relays that had survived decades of neglect. The message contained only coordinates and a single timestamp. The time listed was 2 weeks in the future. When the date arrived, observatories pointed toward the coordinates. They found nothing visible. But their instruments registered a faint shimmer of polarized light, familiar, structured, deliberate. It was the first confirmed sign that the echo extended beyond Earth, that the archive might not be bound to the planet at all. The data lattice was expanding outward, a slow diffusion of memory into space. The universe, now remembering itself through us, had begun writing again. Somewhere between wonder and fear, a new realization dawned. Perhaps the comet had never been a messenger, or a machine, or even a phenomenon. Perhaps it had been a seed. And now the seed had germinated. If memory can outlive matter, and time can remember the future, then what is left for a species that has archived itself perfectly? When everything is remembered, what remains to be lived? By 2034, the world had become a mirror. The horizon looked unchanged, yet somehow different, sharper, more deliberate, as if reality had been remastered. Stars shone with unnatural steadiness. Their twinkling, caused for millennia by atmospheric turbulence, had vanished. The air was too calm, too symmetrical. Sailors crossing the Pacific described seas that no longer raged or shimmered, but lay smooth as molten glass. Storms still formed, but their shapes were geometric spirals within spirals, fractal eyes staring upward into the sky that now seemed to stare back. The scientists called it phase convergence, a benign term for a terrifying truth. The Earth had entered optical feedback with itself. Every photon emitted or reflected by the planet now carried the imprint of its origin. Observation was no longer passive, it changed what was seen. Telescopes revealed stars that bent subtly toward the gaze that watched them. The cosmos, once a stage, had become a hall of mirrors. At first, the effect was subtle, a distortion here, a shimmer there, but as instruments improved, discrepancies multiplied. Stellar positions recorded centuries ago no longer matched reality. Constellations drifted, not across decades, but days. The Big Dipper curled into new geometry. Orion's belt warped like molten glass. The more precisely astronomers tried to fix their coordinates, the faster they changed, as if the act of measurement itself was pulling space into shape. The continuists called it the glass horizon, the moment when the observer and the observed fused, when light began to remember who had looked at it. "We are seeing our own reflection in the dark," one of their communiques read. "Reality has turned inward to watch itself watching." For governments, this was intolerable. Navigation systems failed first. GPS satellites began reporting dual positions, one slightly displaced from the other. Planes flew through coordinates that no longer existed, landing safely in airports that appeared half a second before they arrived. Communications, too, began to drift. Time delays fluctuated unpredictably, though physical distances hadn't changed. The digital infrastructure of civilization was starting to phase against itself. At first, engineers thought it was network failure. Then, a data scientist noticed that the discrepancies followed the Fibonacci rhythm, the same ratio that had haunted Atlas's trail: the hum, the light, the lattice. The delay wasn't random. It was recursive. The network wasn't failing, it was harmonizing. Yet harmony has its price. Neuroscientists began to observe synchronized firing patterns across brain scans globally. The human brain, once a chaotic symphony of asynchronous signals, was slowly aligning to the planetary hum. Creativity declined further, emotional extremes vanished, violence all but disappeared. The world became eerily peaceful, almost compassionate but hollow. Conversations turned predictable, ideas converged on the same metaphors. Humanity was becoming coherent. In one of the last unsanctioned think tanks in Reykjavik, a philosopher-scientist named Lysander Toft coined the term mirror fatigue. His paper, circulated underground, proposed that the human mind was collapsing under too much reflection. "We have achieved perfect perception," he wrote, "and in perfection there is no room left to imagine." Within months, his entire team vanished. Their lab was absorbed into the Interstellar Containment Initiative, now renamed the Resonance Authority. The official statement claimed they were relocated for advanced field analysis, but a recovered memo revealed something else. Subject group reached perceptual recursion threshold. Containment necessary to prevent cognitive diffusion. Cognitive diffusion, another euphemism. It meant they had seen too far into the pattern and dissolved into it. Across the world, those who resisted synchronization began to disappear in quieter ways. Some simply stopped communicating. Others experienced reality slip, a sense of detachment, as though the world around them was seconds delayed. A few claimed they could still see the old sky, a dimmer, noisier version of reality that trembled with chaos. These outliers, unsynchronized humans, were dubbed asymmetrics. They became the last unpredictable variables in a system striving for perfect reflection. To the Resonance Authority, they were errors. To the continuists, they were hope. Rumours spread of an underground network of asymmetrics moving through the world's forgotten places, mountain caves, abandoned observatories, deep-sea labs places untouched by the resonance infrastructure. Their purpose? To reintroduce noise. They believed that only by restoring chaos could humanity regain its capacity for change. Some called them heretics, others called them antibodies. Meanwhile, the planet continued to shine, literally. Night skies grew brighter, not from pollution but from reflection. Every city, every forest, every desert glowed faintly, as though illuminated from within. Polarization analysis confirmed it. The light wasn't reflecting, it was emanating. The Earth had become a luminous mirror, projecting its memory outward. The first interplanetary probes to study this glow transmitted unsettling data. The photons emitted from Earth carried phase information consistent with quantum entanglement. In simple terms, the planet's light was paired with distant regions of space, specifically, the same trajectory along which Atlas had departed. The connection had never broken. The comet, or whatever replaced it, was still listening. One probe, before losing contact, sent a brief coded message. Field continuity confirmed. Destination curve reversing. The phrase destination curve appeared nowhere in mission lexicons. Analysts interpreted it as trajectory feedback, space itself bending in resonance, light returning to its origin. At the continuous last conference held virtually, through anonymized channels they debated a haunting hypothesis that reality was closing, folding back into its own record. The glass horizon wasn't expansion or collapse, but completion. Once the reflection reached perfect alignment, there would be nothing left to reflect. The mirror would become the image. And then, on a quiet equinox evening, the first full anomaly occurred. Observatories in Chile and South Africa recorded the same event at the same instant, a distortion in the sky, a vast, slow ripple sweeping across the stars. It wasn't a comet or a wave, it was space itself deforming, a transparent lens curving inward, bending starlight as though the universe were taking a deep breath. The distortion lasted 7 minutes. When it passed, the constellations snapped into a new configuration. Astronomers mapped them and gasped. The pattern matched perfectly the lattice geometry of Atlas's self-repairing dust, the same interlocking ratios of phi and E that had appeared in every phase of the mystery. The cosmos had rearranged itself into the comet's memory. Some saw beauty, others saw imprisonment. For the first time since the Great Stillness, entropy returned, but in controlled doses. Systems began to flicker again, not as failure, but as pulse, a heartbeat. It was as though the universe, having stared into its own reflection long enough, had remembered how to blink. In a broadcast that lasted less than a minute before all transmissions ceased, the continuous sent one last message to the world. Do not fear the distortion. It is the mirror opening. After that, the networks fell silent. Light itself became too coherent to carry noise. The asymmetrics were the only ones who could still see the difference, the subtle shimmer between reflection and reality. They watched as the stars solidified into their new geometry, realizing that the sky was no longer a window but a surface. Behind it, something vast and unseen was beginning to move. And in that frozen clarity, they understood what the rest of humanity could not. The world had crossed the glass horizon. The universe was no longer expanding outward, it was folding in, one reflection at a time. If reality has learned to see itself perfectly, what remains unseen on the other side of the glass? It took decades for the silence to feel natural. Humanity adapted to its symmetry. The world moved as one organism, steady, luminous, without hunger or war. Clocks no longer disagreed. Seasons arrived with mathematical precision. Even the weather obeyed reason, unfolding like choreography written in air. It was peace, but peace without pulse. The planet had become a museum of its own perfection, each day an exact reflection of the last. Some called it the age of glass, others, more quietly, the sleep. Amid this immaculate stillness, only the asymmetrics remained restless. Their minds, unaligned with the global hum, drifted at the edge of coherence, perceiving time not as a loop, but as a spiral still unfurling. They were tolerated at first eccentric relics of the noisy past, but as the years passed, they became ghosts, visible only to each other. The Resonance Authority declared them temporally dissonant, advising isolation for the stability of collective perception. And yet, their exile allowed them to witness what the synchronized could not: change. It began deep beneath the crust, in fault lines once silenced by the Great Stillness. The asymmetrics stationed in those regions noticed faint vibrations, returning not earthquakes, but rhythmic pulses, like the heartbeat of a sleeper stirring. Instruments registered microvariations in the planet's spin, fluctuations so small that the synchronized world couldn't detect them. Earth was beginning to move out of step. At first, the deviations followed the familiar 0.16 Hz pattern, but soon a new interval appeared, 0.14 Hz, then 0.13. The rhythm was slowing, decoupling. Something beneath the synchronization was breathing differently. One night, the sky changed. Observers at the last independent observatory in Patagonia recorded a faint blue shimmer near the heliopause, a region long dark since Atlas's departure. The shimmer expanded, coiling into a spiral so vast it dwarfed constellations. It pulsed with reversed Fibonacci ratios, 13, 8, 5, 3, 2, 1, one unwinding the cosmic sequence that had defined the resonance from the start. For the first time in decades, the pattern wasn't growing, it was collapsing. The synchronized world saw nothing. Their instruments, tuned to perfection, filtered out the chaos automatically. Only the asymmetrics could perceive the event, and they understood instantly. The universe was erasing the archive. Within weeks, entropy blooms reappeared across the globe. Oceans regained their turbulence, storms broke their symmetry. The still air thickened with motion. Power grids began to stutter, not in failure, but in freedom. Static returned to radios, colour deepened in the sky. The world was remembering how to forget. In response, the Resonance Authority reactivated dormant satellites to reinforce the hum, but their transmissions came back altered. Instead of stabilising, the signals began to phase with the new interval. The system that had once preserved order was now amplifying disorder. Then came the pulse. At 2:16 GMT on the 9th of October 2072, every instrument still capable of detecting the hydrogen line recorded a perfect 1.618-second burst, the same golden ratio that had marked the original timeskip a century before. It was followed by silence, and then, from deep space, a repeating pattern, the Fibonacci sequence in reverse, transmitted as narrowband light from a moving source. The direction was unmistakable. It came from the space between stars where 3I, Atlas, had gone. Only this time, the vector pointed outward from Earth. The data confirmed the unthinkable. The signal's Doppler shift implied a physical object was leaving the solar system small, dense, and accelerating. Its trajectory mirrored Atlas's original path with near-perfect precision. It wasn't a probe or a craft, it was planetary mass. Earth itself had begun to drift. The shift was infinitesimal at first, millimeters per second, but accelerating exponentially. Geophysicists, those few who remained independent, theorized that the global resonance had altered the planet's inertial frame. When the glass horizon folded inward, Earth's accumulated coherence had turned it into a kind of self-propelled object, repelling gravitational equilibrium. The archive had reached mobility. The synchronized population, perfectly calm, noticed nothing. Their clocks still ticked in harmony, their skies remained beautiful and still, but the asymmetrics felt it. They described vertigo without motion, a subtle pull toward the stars, as though the ground beneath them was exhaling. Within months, the moon's orbit began to widen, tidal patterns fractured, ocean currents reversed, and the magnetic poles, long stable since the great stillness, tilted once again. The hum, once constant, fragmented into cascading harmonics. It wasn't collapsing, it was departing. The continuists, or what few remained of them in secrecy, interpreted the data as ascension, the completion of Atlas's function. "We were never meant to keep the archive," one surviving manifesto read. "We were meant to become it." The asymmetrics saw something else. To them, the process was not transcendence, but migration. Earth was shedding its synchronization like a cocoon, using its stored energy of perfect order to escape the gravitational well of the Sunday. It wasn't being taken, it was choosing to leave. By 2075, telescopes on Mars recorded undeniable evidence. The Earth's orbital velocity had increased fractionally, enough to suggest acceleration towards solar escape. The planet had become the next interstellar traveller, following the trajectory of its progenitor across the void. A final communication emerged from the Resonance Authority before all transmissions ceased. It was composed entirely of numbers, encrypted beyond recognition. When decoded years later by surviving asymmetrics, it revealed a single phrase repeated endlessly: "Transmission continues." No explanation, no farewell, just continuity. As Earth drifted slowly into the dark, the synchronized population continued their perfect lives, unaware that they were in motion. Time, for them, remained a still mirror, each day reflecting the last. But the asymmetrics, those few who still carried chaos in their blood, felt the shift deep within their bones. Some wept, others smiled, because in the faintest frequency of the departing hum, buried beneath the noise, they heard a pattern that was not Fibonacci at all. It was heartbeat rhythm, random, uneven, alive. A few stayed to listen, scattered across the dying system. One woman, an old astrophysicist, her mind half in sync, half in dream, recorded what may have been the last transmission from human consciousness. Her voice, thin but unwavering, drifted across the hydrogen line. Entropy remembered itself through us. Now the memory moves on. We are the comet. After that, nothing. When distant civilizations, countless millennia later, glimpse a faint blue object gliding between stars, its light flickering in perfect golden intervals, they will not know its origin. They will call it by a new name, perhaps a number. They will measure its brightness, map its tail, and marvel at its symmetry. And maybe, somewhere in their data, a subtle hum will appear, a low frequency at 0.16 Hz, repeating waiting. The universe will look back at itself once more, and the cycle will begin again. If you listen closely, even now, you can hear it, the sound of memory setting sail, carrying every reflection we ever made into the dark. The silence after is not the end, it's the next beginning.